So, hey guys, welcome back to my YouTube channel. So, for today's video, I will do a summary of Chapter 8, Subnetting IP Network. So, let's proceed. So, we have here the section and objectives, and 8.1, Subnetting an IPv4 network. So, we all know the broadcast domain devices are broadcast is in an Ethernet LAN to locate. So other devices address resolution protocol ARP, which send layer 2 broadcast to a known IPv4 address on the local network to discover the associated MAC address. So dynamic host configuration protocol, or DHCP, which send broadcast on the local network to locate the DHCP server. So switches propagate broadcast out all interface except the interface on which is received. So problems with large broadcast domain. Hosts can generate excessive broadcasts and negatively affect the network. So slow network operation due to significant amount of traffic it can cause. So slow device operation because a device must accept and process each broadcast packet. So as you can see in the figure, two figure, it has a one broadcast domain, and uh, in the second figure it has two LAN and broadcast in LAN one contained in one subnet, and then the broadcast in LAN 2 contained in one subnet. So reasons for subnetting, so reduces overall network traffic and improves network performance. So enables the administrator to implement security policies such as which subnet are allowed or not allowed to communicate together. So communicating between networks. So as you can see, we have a subnetting by location. So we have 5 switches in this building. So we have a one network. So as we have a LAN 1, LAN 2, LAN 3, and so on. So we have a administrator, which is LAN 1, and LAN 2 is student, and LAN 3 human resources, and LAN 4 is accounting. So we have here, so octant boundaries. So network are most easily subnetted at the octant boundary /8/16 and /24. So the prefix length is 8/8, and the subnet mask is 255.0.0.0, and the subnet mask in binary n equals network and h equals to host. So as you can see, we have a here 255, which means it is the network, and then we have a 0.0.0, which means it all are hosts. So number of hosts in /8 is 16,777,214, and then we have a and so on. So prefix length and the subnet mask are different ways to identifying the network. So portion of an address. So subnet are created by borrowing host bits for network bits. So more host bits borrowed, the more subnet that can be defined. So let's proceed. So subnetting, then so ending, we will not subnet video demonstration. We already know that, and then we already know that. So here's the formula for subnetting formulas. So we have here subnetting a /24 network. So we have an IP. We have a network 192.168.1.0. So our our network is 192 and 168 and that one. So our host is 0. So we will calculate number of subnet formulas. So we will use this n bits borrowed. So here we have 2. As you can see, we have a 1 1 2 4 8 16 32 64, and then we have 1 2 3 4 5 6. So we have a borrowing 1 bit, so which means 2 raised to 1 equals 2, and then so on. You have to double it, so you have to minus 2. So as you can see is then already know that. So creating subnet with a /16 prefix. So as you can see, we have a subnetting a /16 network. We have a 17, 18, 19, 20, and so on. It is easy to understand the prefix length and the subnetting. Again, here we go again with creating 100 subnet with 16 prefix. As you can see, we have a network and host. So which means you will borrow again. Borrow and borrow. So already know that. Again, as you can see, it's all the same pattern for this formula. So as you can see, we have a 10.0.0.0, so we will borrow 10. So as you can see, we have a 10 bits. Demonstration, subnetting. So subnetting based on the network requirements. So host devices by employees in the engineering department in one network and management in a separate network. So network requirement example, again, here's the um, network portion, host portion. It easy. So we have network requirement, lab exercise, path tracer, lab, traditional subnetting waste addresses. So here's again is you may you have to not you have to understand the formula because you will not execute the subnetting if you do not understand the formula. So we have a traditional and subnet of varying size, basic VLSM. So as you can see, we have video demonstration, VLSM basic. So subnet do not have to be equal sizes as long as their addresses range do not overlap. VLSM chart. So addressing scheme. So each host in internet network must have unique address. Need proper planning and documentation. Must provide controlled access to server from internal host and external host. So layer 3 static address assigned to a server can be used to control access to that server. Monitoring security and performance of host means network traffic is examined for source IP addresses that are generating or receiving excessive packets. So assigning address to device and devices, so end user client can be set for DHCP to save time and manual error. So DHCP is it can give an unique IP address, and then server configured with static addresses, private addresses translated to public, and then intermediary devices with static addresses for remote management. So gateway router interface used to exit the network. So we have here the network 192.168.1.0/24. So we have here host device .1, server .23, .30, the printers .40, intermediate device .50, 250, and the gateway router LAN interface 254. Okay, the design consideration of IPv6. So we have here the global Unicast address, and IPv6 subnetting is not concerned with conserving address space. So as you can see, we have address block, subnet allocation. So let's proceed, and then so here's the chapter 8 summary. So we have here, so subnetting IP network implement an IPv4 addressing scheme to enable to end-to-end connectivity in a small to medium-sized business network. Given a set of requirements, implement a VLSM addressing scheme to provide connectivity to end user in a small medium-sized network. Explain design consideration for implementing IPv6 in business work. So, in this chapter summary, you have to um, implement a VLSM for you to connect the end devices or user properly. So this is the end of my video, and I hope you enjoy it, and thank you for watching, and thank you. Bye.